say 2 points. Does the derivative exist at P?
Yes. Dalawang tangent, di ba? Bawal.
Does the derivative exist at P? At Q, it looks like this, di ba? At Q. At each of the point, it changes from time to time. Look at that, di ba? Nagiging ganyan. And then this one becomes that.
Hindi.
At P, becomes this. So it becomes positive infinity, right? As you approach to P. For this one, what is the slope of the tangent line here? It's negative, right? It's negative. For this, it also changes. It moves like that. For this, it becomes like this. And then, if it's at P, it becomes a vertical tangent line. Now, what is the slope of a vertical line? Undefined. So, if the slope of the tangent line is undefined, the derivative fails to exist. Does not exist. If you have a vertical tangent line at that point. This is the first case. Vertical tangent line. Okay, so the tangent lines here moves to this direction, and the tangent line at this point moves to this direction. You know, it's moved like this, it moves like this. As Q approaches to P. How about for this one? As Q, the other, say Q minus, Q from the right. So as Q plus approaches P, what happens? The tangent line moves to that direction. So it fails to exist at P. There's also a second case class. So you have a cusp.
Main cusp.
It looks like this.
Story Mountain.
Translate.
Vertical.
Cusp. Bakit kaya cusp ang tawag mo? Hindi ko rin alam. Ako, talagang, I just accepted this wholeheartedly that it's a cusp. Okay. And then I try to move on. And not question about the root word of that. Okay, so what happens here? Say, this is Q from the left again, right?
Yeah.
And then this is Q, another point on the right. Yun lang ibig sabihin ng mga Q's na to. And then this is the P. We're talking about this point. Does the derivative fails exist?
Yes.
Yes.
Is there a tangent line there? So what happens to the tangent lines? It moves to what direction, class?
Vertical.
Diba? It moves to this one. Diba? The tangent line is there. This one, and then it increases, 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 and then at some point it's straight. Right? How about the other one? What happens to the tangent lines there? It
Decreases.
also moves to this direction. Right? So what happens? You have what? From one side, it approaches to what? From this side, it approaches to negative infinity. Positive infinity. For this one, it approaches to what?
Positive.
Negative
Negative.
Negative infinity, di ba? Say this is negative 1, this is negative 2, this is negative 3. If it's like this, to this direction, it goes to negative infinity. So the one-sided derivatives, because since you know that this is a limit, you also have this one-sided derivatives here. One-sided limits. From the left, it's positive infinity. From the right, it's negative infinity. So the limit fails to exist at this point here as h approaches to this point. So, what happens, the limit here, the derivative fails to exist. How about the other one? What happens to this one? It approaches to what? Negative infinity. This one,
Positive infinity.
are you sure it's positive infinity? Look at that. It's negative. Negative, di ba? Pataas, it increases negatively. So this is also negative infinity.
Ano?
Word one.
Hindi ko mag-get.
This tangent line here is negative. Yeah, it looks like this. And then from that, if you
Slope means
move at a certain point again,
May slope po ba?
oh,
Hindi ko
slope.
usapan.
Looks like this. So this is a negative slope, and then this is also a negative slope, but it has a steeper. So mas nagiging steep, di ba? At some point, it is negative infinity. Same also for this one, right? You have a negative slope here, and then it gets steeper and steeper. So it's negative infinity.
Positive.
So the slope of the tangent line here, it's negative infinity. Okay? And then for this one, it fails to exist because the one-sided limits, they are not the same. Tama? They're not equal. Because you can define derivative here in terms of limits.
Miso yung limit ng A negative.
The slope of the tangent line here is negative infinity. Both sides.
So yun may limit.
Infinity. What do you mean?
Kasi parehas silang...
If the slope of the tangent line is either positive or negative infinity, the derivative fails to exist. Because the concept of negative infinity, diba? This number is not defined. This number does not exist. Right? Okay. So the derivative fails to exist if the slope of the tangent line is either positive or negative infinity. For this case, the slope of the tangent line does not exist. Why? Because the tangent lines from the left side, it goes to positive infinity. From the left side, the tangent lines goes to negative infinity, the slope of the tangent lines. So at this point, what happens? It does not exist because it goes on different directions. So the derivative also fails to exist at P here. So we call this scenario here as a cusp. How about the third one? This corner. The derivative also fails to exist in a corner. If your function have this. What is that corner that we're talking about?
Sige.
Okay. What happens to the tangent lines, class?
Intersects.
Say from Q to the right. You get a point on the right of P.
Nagiging horizontal yung banan. Di ba? Kasi ganun. Di ba, Mitch?
So what happens? It goes to 0 from the right. Right?
Horizontal nga.
May sinabi pa naman eh.
Hindi
Wala, di ba?
yung sinasabi na ako.
Kaya nga. Suspense, di ba? So, in this case, it goes to what? Ganon, pinapaasa. And then how about from the other side, class? What happens? From the other
Positive.
side.
Positive.
You have a positive slope for the tangent lines. It does not change at all, right? It does not change at all. So the slopes from the left direction, it's positive, and then from the right, it is 0. So the two are not equal, therefore it does not exist. So the derivative fails. How about for this? Does the derivative exist here at 0? Yes.
Yes.
Because if you see the
It passes through 0.
okay, the pattern of your tangent lines class,
Horizontal.
it becomes horizontal from the right. And then from the left of 0, the tangent lines goes horizontal. So the derivative exists at this point. And it is equal to 0 because the tangent line here is horizontal. You understand?
Yes.
Yes. That's the concept of derivative class. It's all about the slopes of the tangent lines. Okay. We still have one more, wherein the function fails to exist. If derivative fails to exist if there is a jump discontinuity class. Can you think of a scenario wherein there is a jump discontinuity? Like that. So it's still the same, right? The slope of the tangent line here is what? It's 0 there. Goes to 0, it approaches 0. From a negative slope, it goes steeper. Okay, this one, it's steep. And then it is going less steep as you approach this point. In fact, it becomes 0. How about this portion here? It's constant, right? The slope of the tangent line is constant. So, the two slopes, they are not the same in both directions. So, the derivative fails to exist at this point. Okay? So, from this, you would know that differentiability, continuity does not imply differentiability. So you see, if a function is continuous at that point, it doesn't mean the derivative exists. Say for this, you know that the function is smooth, right? At this point. But the derivative fails to exist. Same with this one. It's continuous at this point, but the derivative does not exist. Differentiability class implies continuity. So if you're sure that the slope of the tangent line occurs at a specific point, therefore you would imply that it is continuous likewise at that point. That's for sure. So again, differentiability implies continuity, but continuity does not imply differentiability. Questions? None? I'll give you a shortcut way to solve for the derivatives. So we have this one. First one. Time na ba? Oh my God, it's time already.
Miss, may tanong ako.
What's your question?
Pwede po yung sadyang discontinuity. How if the right graph will be straight? Will be a straight line. Parang gano'n. Parallel, para kung parallel.
Isa ko yung tanong ko kung pag gano'n naman yung kabila.
Parallel.
Yes, parehas.
I guess,
Yes.
Pero pagdating naman dito, I could have a tangent line that looks like that.
is kung parehong,
Ay, parehong ganun pala.
Pag yung parehong curve.
yung una po, is
Pag ganun,
siya.
tas-
So, nagiging 0. Tapos yung kabila.
Kasi pag sasabihin mo namang tangent line, it would pass that one at one point only. So, for this,
Ang bawal.
your tangent line can look like this, or it can be a vertical line also, class. Same with this, it can be that one, but it can be a vertical
So,
line.
miss, pag
like
discontinuous, walang tangent.
Diba? I told you,
Kasi dalawang
continuity
point.
does not imply differentiability. O di kung discontinuous, you're sure that it is not differentiable at that point. If it's differentiable, then you're sure it is continuous at that point. So if it's a jump discontinuity at this point, therefore automatically, it is not differentiable at that point. Tama? Sige, next meeting nyo na yung techniques of integration. So,